So today we are going to talk about the hydrogen-oxygen fuel cell. So for hydrogen-oxygen fuel cell, if you remember, we have two ways to categorize the chemical cell. So for the chemical cell, we can categorize based on whether they are rechargeable or not. If it is rechargeable, then we call that secondary cell. While the other one, if it is not rechargeable, we call that primary cell. While the other type, we depends on the type of the chemical cell. So we have categorized them into three: dry cell, wet cell, and the last one is fuel cell. So for fuel cell, can they be rechargeable? They're primary cell or secondary cell. Many of you think that if we just put hydrogen back into the fuel cell, then actually it can be reused. Yes, that's correct. However, rechargeable is not talking about that way. Rechargeable means that we can apply electricity, we provide electricity to it to charge it back, just like your mobile phone. So you will find that fuel cell is something like the car. So the car cannot keep on going without the fuel. So if you find that your fuel tank is getting low, you have to apply fuel. You have to fill up the fuel tank, put back the fuel. So in this case, we say that the fuel actually they are not reusable. We're just adding some new fuel in it. So therefore, fuel cell, for hydrogen-oxygen fuel cell, number one, you have to remember this one is not rechargeable. So it is a type of primary cell. And it is called hydrogen-oxygen fuel cell. So you will find that hydrogen and oxygen must be included in the fuel cell. But what are the roles of the hydrogen-oxygen fuel cell? I just want you to remember for a fine triangle. For a fine triangle, you should have three things. So in order to have fire, first of all, you need to have fuel, you need to have oxygen, and then you have high temperature. So in this case, we can see that inside the fuel cell, the oxygen itself, is one of the requirements for having fire. Sometimes we call it oxygen, sometimes we call it oxidant. So for oxygen, indeed, actually, it is an oxidant. While hydrogen, hydrogen, it is the fuel. So the second thing you have to remember is, the fuel we are talking about the hydrogen, while the oxidant, it is the oxygen. So normally for chemical cells, we also need an electrolyte. So what kind of electrolyte are we going to use this time? The one that we use is hot concentrated potassium hydroxide. So remember this time is hot concentrated potassium hydroxide. So you can see that with the hydroxide, the whole reaction is occurring in an alkaline media. So for the balancing equation, you have to pay attention to that. So let's have a look of the setup of the hydrogen fuel cell. So for the hydrogen-oxygen fuel cell, so you refer to page 14. You will find that we got the fuel, just now we mentioned, and then we also got the oxidants. So you got fuel here, and you got oxidants. And then for the electrolytes, we'll have hot concentrated potassium hydroxide, which is the electrolyte. And for the electrode, we use porous electrode. Porous, if you remember, that means they got holes in it. So that the oxygen and the hydrogen can pass through and things like that. So all the hydrogen go inside, react, and then some of the unreacted will leave here. Same happen to the other side. The oxygen go in, do like that. So the reactions will occur at these two electrodes. So let's have a look, of what happens, for the two electrodes. So what kind of reaction we are going to have. So for the chemical reaction involved, before we talk about the cathode anode or half equations happen there, the very first things I want you to remember, every single one of you have to remember, is the overall reaction. Because this one is so simple. You have hydrogen, you have oxygen react, the product must be water. So even you don't know the half equation for the anode and cathode, okay, I hope that you can remember the overall reaction. So now we move on, okay, for the oxygen and hydrogen, what kind of reaction are they having? Okay, so for the oxygen, very simple, because this one is an alkaline media. Remember, alkaline media always in your mind. Okay, because it's an alkaline media, okay, the one that you can do to balance the equation, you should have like H2O, you can have hydroxide ion, and also electron. Remember, this time we shouldn't use H plus because OH minus will react with it. Okay, so for oxygen, okay, bear in mind, okay, all the time we have like hydroxide ion. Okay, so remember the four that we have memorized before, so it will be simple for us to balance the whole things. So we have like things like that. Okay, so for this one is happening at anode or cathode, we can very quickly to check. So this one is 0 and this one is -2. So from 0 to -2 is a reduction. So therefore this one is a cathode, happen at the cathode. So while the other side, okay, that will be at anode. So this is the part that you always makes mistake, because when you write hydrogen, you very quickly to write H plus and then electron. Okay, so this one is so or spontaneous for you to do that. But remember, hydrogen is not allowed, okay, in this reaction because, okay, it is an alkaline media. So what we can do is to react the H plus, okay, by adding hydroxide ion, okay, to help me. So I will put like 2 hydroxide ion on both sides. So you can see that 2H plus 2 hydroxide ion, and then this one will then become water. So you have like 2 water on the right hand side, while the other side, okay, you have H plus and OH minus. Okay, so by doing this, okay, you can just multiply the equation at anode by 2 and then multiply this one by 1, then you will find that the electron will then be eliminated and then the water, okay, will remains. Okay, so one thing forgot, okay, is about the overall equation. I didn't balance this one yet. Okay, so if you balance it, you find out that way. Okay, so you can check right now. If this one by multiplied by 2, then you got 4 H2O on the left hand side, while we've got 2 H2O on the left hand side. So this one will eliminate, become 2 H2O. So you have 2 H2O on the right. Okay, and this one, if you multiply by 2, then you got 4 hydroxide. So 4 hydroxide and 4 hydroxide will be eliminated. So the hydroxide will disappear, and then this one will multiply by 2, this one will multiply by 1, so you got 2H2 and 1 O2. So this is what we are doing, okay? So I just emphasize, okay, you have to remember how to write this hydrogen half equations using alkaline media. Okay, you can first balance away using hydrogen, but remember afterward you have to add the hydroxide ion to eat the H plus that you have used. Okay, so this is a chemical reactions involved. So next we're going to talk about the porous electrodes. Okay, the electrode that we have used, okay, normally it will be nickel or platinum. So this one is called porous, okay, that means with holes in it. So in the public exam, you will be asked about the function or the usage of the porous electrodes. So among these 3, I recommend the first one and the last one, okay, because it's commonly seen in the public exam. Okay, so they will act as a electrical conductors to connect the fuel cell or to the external circuit. Okay, so it will just conduct electricity and as a conductors, while the other one, okay, more important, okay, it will be catalyze the reaction between the hydrogen and oxygen. It's just like a catalyse. Okay, so normally, okay, we're just referring to the metal is nickel. So we add as a catalyst to speed up the reaction between the hydrogen and oxygen. While the other one, you can see that they have holes in it, so therefore they will allow the flow of hydrogen and oxygen, okay, to get into and out of the compartment. But more of the one that I prefer will be the first one and the third one. Okay, so next, okay, will be the advantage. Okay, why we are talking about hydrogen oxygen fuel cells so special? Okay, because they have a certain major advantage. The first one, okay, it will say that they operate continuously and produce steady supply of electricity. Remember, steady supply. If you remember the discharge curve, okay, it will be a flat discharge curve. So it won't be a sloping run, okay? So therefore, the current that produced will be quite steady. So it won't be like sometimes will be bright in light providing, sometimes the light will be dimmer, and dimmer, things like that, okay? So this one operate continuously, so therefore can produce steady supply. While the other one, okay, we find that a high efficiency of energy conversion. Remember, the most important part is energy conversion. Many of you just say that, oh, we have a high efficiency. High efficiency on what? So it will be high efficiency of energy conversion. Just give you one example. If you talk about a car, okay, okay, so we supply 100% of fuel, we put in it, okay, is it all the fuel will be converting to the kinetic energy that we concern the most? So maybe not, okay, maybe like only 20% will go to the kinetic energy. For the rest, okay, it may be turned into heat. So you find that it is not very effective, okay, it is not a heater, right? Okay, so what you want is the kinetic energy. So in this case, we find that the efficiency of the energy conversion is very weak in a car, but in the hydrogen oxygen fuel cell is much better because efficiency is about 70%, okay, only 30% of them is turned as a heat. So the important thing is, okay, the advantage is it got a very high efficiency of energy conversions, okay. Most of them can convert into electrical energy, while less of them will be converted into heat, okay. And the third thing is very important about the hydrogen oxygen fuel cell is in the product just now you saw that, okay, we just have H2O as the only product. Remember, only, this word is very important. It's as the only product is a water. Water is non-polluting, and in some area we can even drink it. For example, later on you learn that hydrogen oxygen fuel cell will use it in space shuttle. So in space shuttle, you don't have enough water. Then at that time you can drink the product in the hydrogen oxygen fuel cell because they are non-polluting. Okay, so not like the other chemical cell, okay, they may generate like CO2, SO2, NOx, these kind of things, okay, they may pollute the environments. So remember, the keyword is goes to only products, okay, which is non-polluting. So you may also want to like to add words like environmental friendly. So these kind of keywords, okay, you always environmental friendly. We always see that, okay, in the public exam. So among these three advantages, I prefer you to use number 2 and number 3. Okay, so please memorize it. Okay, and then it must have some drawbacks. Okay, so the drawback is not easy to store. You imagine, okay, I need to have a tank of hydrogen or a tank of oxygen at home to use that. Okay, so these kind of things is flammable. So like pressurized gas is not easy, okay, explosive or things like that, okay. It's not okay to store that large amount or transport like a large amount around, okay. So therefore it's not easy to store and transport. It's not good to use it, okay. While the other one is the fuel cell itself, okay. The hydrogen and oxygen, these are the fuel and oxygen, but the compartment, the fuel cell itself, okay, to build this one is quite expensive because normally we'll just involve platinum and nickel, okay, to make the electrode. So these two kind of metals are quite expensive. So therefore it's not commonly used, okay, in our daily life. So then when are we going to use the hydrogen oxygen fuel cell? So in the textbook, page 16, you can see that there are 3 examples there. So you just memorize some of them mainly, okay, you can find the question in the MC, okay. So the first one, okay, we'll use it at a remote power sources for space explorations, just how we mentioned, okay, because the product is quite clean, okay, we can drink it, we can use it, okay, no pollutants, okay, and at the same time, so you can generate a large amount of fuel, okay, a large amount of energy, the energy conversion, high efficiency energy conversion. So therefore, we'll use this one, okay, in a space explorations, okay. Also, you have mentioned, okay, it can work continuously, okay, and current it produces, okay, quite steady. So all these things, okay, is a benefit, okay, to use in remote area. So the remote power resources like spacecraft, and also we can produce drinking water for astronauts to use it. Okay. Other than that, we can use it as a backup power sources, okay, because they have a low level of noise and air pollution. This one is not very important, Okay, so but anyway, you just memorize it's a backup power resources will do. Okay, and the last one, okay, is more common that you can see. Okay, is a high energy efficiency of energy conversion. So therefore, we just like use it in the car. Okay, and also we'll just like cause less air and noise pollution. So you will see that more than it will be in the electrical vehicles. Okay, so like this one, high fuel cells. Okay, so in conclusions, okay, you for this section, so you have to remember the components of the fuel cell. What is the fuel? Hydrogen. What is the oxidant? Oxygen. What is the electrolyte? It is a hot conc, KOH, okay, and the electrode normally use nickel and platinum, okay, so they are expensive electrode, okay, they are porous, okay, but the functions of it, okay, will be like catalyzing the reaction, catalyzing the reactions, okay, and also like they will just add as a electrical conductor, so electrical conductor. Okay, and then you have to remember the reaction involved. Remember, it's an alkaline media, so remember no H plus involved. Okay, so at least you have to remember the overall reaction. So even you don't remember the cathode and anode half equation, you still have to remember the full equation. So advantage, drawbacks, okay, the main advantage, it will be like no pollutants produced, water as the only product. It can be like high efficiency and energy conversion. The drawback is things is the fuel cell itself is quite expensive, and also it is difficult to store the hydrogen or oxygen, the compressor gas, the explosive, things like that. The usage, okay, maybe like the remote area, like the space shuttles, like using in the electrical vehicles and things like that. Okay, so that's all for this video. Bye bye.